Hey guys, sorry, my video stopped recording, so let me start that again. So remember, I want you to remember when you're working with radians and you're trying to figure out what quadrant those angles land in. Remember I call them anchors. That's what my teacher called them, and I'll never forget them teaching me to that. So just remember your two main conversion factors with radians though. One complete rotation around a circle is 360 degrees. One complete rotation around a circle is 2 pi radians. And then we can simplify that conversion by dividing by 2, and then we get our other conversion that 180 degrees is equal to pi radians, okay? All right, so your anchors, what am I talking about? Well, there's three main angles that we kind of work with, and those are your 30s, your 45s, and your 60s, because those are the three angles that come directly out of our special right triangles, our 30, 60, 90, and our 45, 45, 90. Because they come out of those special right triangles that have that special or specific side length ratio, and trig is all about right triangles, these angles and multiples of these angles pop up all the time. And these are the ones that you're expected to know off the top of your head. So I want you to know them inside and out and where they land and who is who. So you have to remember that 30 degrees in radians, that's your pi over 6. 30 degrees is pi over 6 radians. And I always remember that because if pi is 180, then 180 divided by 6 is 30. So that's 30 degrees in radians. All right, then you have 45 degrees. He's your pi over 4. All right, 180 divided by 4 is 45. So 45 degrees in radians is pi over 4 radians. All right, you go to the snack drawer. Oh, Zach, hurry up. Sorry, my son's needing something. All right, and then you have 60 degrees, right? 60 degrees is pi over 3 radians because 180 divided by 3 is 60. So you really should get familiar with these three angles in their radian measure. So pi over 6, pi over 4, and pi over 3. You're going to see them a lot. All right, so what are these anchors? Well, if you're working with pi's over 6, 30-degree angles, well, I want you guys to remember something. In radians, we have 0 radians in the exact same spot as 0 degrees. And then when you rotate all the way around, right, that's 2 pi radians. So in the world of pi's over 6, how many pi's over 6 get you all the way around and equal 2 pi radians? 12 pi's over 6. So that's where 12 pi's over 6 live, right here at this line. So if you were ever wondering, where do 11 pi's over 6 land? They're going to land in the quadrant before 12 pi's over 6. If you were wondering, where do 13 pi's over 6 land? They're going to land right back in quadrant 1 after the 12 pi's over 6. All right, so that's one of your anchors. In terms of pi's over 6, 12 pi over 6 is one of your anchors. Well, we can also get an anchor on this side. If halfway around a circle is 180 degrees, that's also pi radians. So that's where pi radians lands. Well, how many pi's over 6 make pi? That would be 6 pi's over 6. So 6 pi's over 6 is an anchor that we use. So if you were ever wondering, where do 5 pi's over 6 land? Well, 5 pi's over 6 are going to land in the quadrant before it. 7 pi's over 6 are going to land in the quadrant after it. So we use this as anchors. And you can also use it to count. So if this from here to here is 6 pi's over 6, that means it takes 6 pi's over 6 to get halfway around. So if you go another halfway, right, 6 pi over 6 and 6 pi over 6, that's 12 pi's over 6. And I can keep going. So from 12 pi over 6, oh, not on the screen, sorry, 12 pi over 6, if I go again another halfway, that's going to be 12 pi over 6, 6 more. This is where 18 pi's over 6 land. And then I can do it again. Go another halfway. Go another 6 pi over 6. That's going to be, well, 6 pi's over 6 away from him is going to be 24 pi's over 6. And then you can use them as anchors. So if this is where 24 pi's over 6 is, then 23 pi's over 6 lands in the quadrant before it. 25 pi's over 6 lands in the quadrant after it. And the same thing, you can use 18 pi over 6. If you were wondering where 17 pi's over 6 are, they're going to be in the quadrant before it. 19 pi's over 6 are going to be in the quadrant after it. You use these as anchors. So 6 pi over 6 and 12 pi over 6 are your anchors when you're working with pi's over 6's. Well, what about pi over 4? What if you're working with your 45-degree angles? Well, remember, you start right here at 0 radians. If you go halfway around, that's pi radians. That's 180 degrees. So how many pi's over 4 make pi? That would be 4 pi's over 4. So this is where 4 pi's over 4 live. So 3 pi's over 4 are going to land in the quadrant before it. 5 pi's over 4 are going to land in the quadrant after it. And then if you go all the way around, that's 2 pi radians. Well, how many pi's over 4 make 2 pi? That would be 8 pi's over 4. So this is where 8 pi's over 4 live. So 7 pi's over 4 are going to land in the quadrant before it. 9 pi's over 4 are going to land in the quadrant after it. And then I can use my 4 pi's over 4 to kind of rotate around. So like I said, 0, 4 pi over 4, 8 pi over 4. Every 4 pi's over 4 gets you halfway around. So if I'm at 8 pi's over 4, 4 pi's over 4, that would get me at 12 pi's over 4. So this is where 12 pi's over 4 live. So 11 pi's over 4 are going to land in this quadrant. 13 pi's over 4 are going to land in that quadrant. And these anchors, as I call them, they get you perspective as to how many radians get you in what quadrant. All right? So again, your main anchors with pi over 4 are your 4 pi over 4 and your 8 pi over 4. And you can use them to kind of help and see where each angle's going to land. All right? Well, what about pi over 3? What are your anchors when you're working with a 60-degree angle? Pi's over 3. Well, remember, if you're working with pi's over 3, then you start here at 0 radians, and then you rotate halfway around, gets you at 180 degrees, or pi radians. So how many pi's over 3 make pi? That would be 3 pi's over 3. So that's an anchor. So if that's where 3 pi over 3 is, then 2 pi over 3 land in the quadrant before it. 4 pi's over 3 land in the quadrant after it. And then again, if you rotate all the way around a circle, that equals 2 pi radians. Well, how many, if we're working with pi's over 3, how many pi's over 3 make 2 pi? That would be 6 pi's over 3. So now 5 pi's over 3 are going to land in the quadrant before it. 7 pi's over 3 are going to land in the quadrant after it. And then again, you can use this to count. If halfway around is 3 pi over 3 radians, well then if I'm already all the way around at 6 pi over 3, if I go halfway again, 3 more pi's over 3, this is also where 9 pi's over 3 are going to land. Add 3 pi's over 3. So that means 8 pi's over 3 are going to land in this quadrant, 10 pi's over 3 are going to land in the quadrant after it. And then again, if I'm at 9 pi over 3, if I rotate halfway around again, that's another 3 pi over 3. So 9 pi over 3 plus 3 pi over 3, that's 12 pi's over 3. Okay, and that's another anchor. So now if that's where 12 pi's over 3 land, 11 pi's over 3 are going to land in this quadrant, and 13 pi's over 3 are going to land in the quadrant after it. I use these as my anchor. So your main anchors are your 3 pi over 3 and your 6 pi over 3, and you can use that to predict where they're going to land. All right, so please keep that in mind if that helps. All right, let's go back to our reference angle. So again, instead of you, where did I leave off? Instead of you having to count 5 45-degree angles, 1, 2, 3, 4, 5, you should be able to create an anchor out of pi's over 4. If this is where pi radians live, then this is where 4 pi's over 4 are going to be. And the fifth one is going to be in the quadrant after it. Okay? All right, let's try this one. What if you had 2 pi over 3? What is the reference angle to 2 pi over 3 radians? Well, again, you can think of this as 2 pi's over 3. So that's two 60-degree angles. I don't want you to forget that if it helps. That's two 60-degree angles. So two 60-degree angles would land, well, the first 60, the second 60 would be 120. It would land in quadrant 2. But if you use your anchor, well, think about it. I'm working with pi's over 3. So if this is pi, then that makes 3 pi's over 3. So where's the second pi over 3 going to be? In the quadrant right before it. And then the fourth pi over 3 would be in the quadrant right after it. So if you have 2 pi over 3 radians, that rotates all the way to there in quadrant 2. That's 2 pi over 3 radians. So your reference angle is the angle in between your angle and the x-axis right here. Okay, well, think about it. How many pi's over 3 live in between 3 pi over 3 and 2 pi over 3? 1 pi over 3 is your reference angle. Okay, well, I have a problem right here, but it looks like my marker covered it up. It is asking you for the reference angle to 7 pi over 6. Well, first we got to figure out where does 7 pi over 6 land. So let's draw it. Well, you can think of this as 7 pi's over 6, right? So that's 7 pi over 6, 30-degree angles. 7 30-degree angles. But if you don't want to think about it like that, you're working in terms of pi's over 6, right? So set your anchors. So if this is where pi lives, then how many pi's over 6 make pi? 6 pi over 6. So the 5th pi over 6 would land in this quadrant, which means the 7th pi over 6 would land in this quadrant. Okay, and then what is the reference angle? The reference angle is the angle in between your angle ending and the x-axis. So this was our original angle. This is our reference angle. So theta is going to be, well, how many pi's over 6 live in between 6 pi over 6 and 7 pi over 6? 1 pi over 6 is the reference angle. Now again, you can also count 7 30-degree angles. 7 30-degree angles, when we think about it, 30, 60, 90, 120, 150, 180, 210. So that would be 1, 2, 3, 4, 5, 6. Your 7th 30-degree angle is definitely in quadrant 3. All right, well, let me do one more because I feel like I didn't do any in quadrant 4. So let's say they wanted the reference angle to, let's say 7 pi over 4. What is the reference angle to 7 pi over 4 radians? Well, let's see where 7 pi over 4 lands. So 7 pi over 4, let's use our anchors. Well, if we're working with pi's over 4, here's pi. How many pi's over 4 make pi? That would be 4 pi's over 4. So the third one would land in this quadrant. The 5th one would land in that quadrant. Well, I'm looking for 7, so I better keep going. So all the way around is 2 pi radians. So if I'm working with pi's over 4, how many pi's over 4 make 2 pi? That would be 8 pi's over 4. So 8 pi's over 4 land right there. That's your 8th 45-degree angle. So where would 7 pi's over 4 be? Right here in the quadrant right before it. So there is 7 pi over 4 radians, right? You could also think of it as 7 pi's over 4, which is 7 45-degree angles, whatever helps. All right, well here, what's your reference angle? What's the angle in between your angle ending and the x-axis right there? How many pi's over 4 live right there? 1 pi over 4. Okay, well, how about this one? What if I asked you, what's the reference angle to 11 pi's over 6? Well, let's see. Give yourself a coordinate plane. If you're working with pi's over 6, you have two anchors. You have your pi and you have your 2 pi. Working with pi's over 6, how many pi's over 6 make pi? That would be 6. So that means 5 pi's over 6 land there and 7 pi's over 6 land there. I'm shooting for 11, so let's keep going. So if this is 2 pi, how many pi's over 6 make 2 pi? That would be 12 pi's over 6. So that means the 13th pi over 6 would be after it, but the 11th would be in the quadrant right before it, right? That's 11 pi's over 6. That's 11 30-degree angles if you want to count it. All right, but this is 11 pi over 6. So what is the reference angle between your angle ending and the x-axis? Well, how many pi's over 6 live in between 12 pi over 6 and 11 pi over 6? The reference angle is 1 pi over 6. Now, that's the one thing I do like about working with radians, and especially when you're working with those special angles, those 30s, 60s, and 45s. The reference angle should always have the same denominator as the angle that you started with. So if you are finding the reference to a pi over 6, then your reference angle should be some version of pi over 6. If you're finding the reference angle to 7 pi over 4, then your reference angle should be some version of pi over 4. All right, so again, reference angles are going to be super, super important in the sense that what we're about to do is we need to be able to make right triangles even if we're going to find the sine, cosine, or tangent of an angle of any size. So what's going to happen is when you're finding the sine of 130 degrees, because that's what they're going to start asking you. They're going to ask you to find the sines and cosines and tangents or cotangents or cosecants of angles of any size. When you're asked to find the sine of 130 degrees, well, 130 degrees doesn't fit inside of a right triangle, but its reference angle will. And since we're going to redefine the trig ratios to use x coordinates, y coordinates, a circle's radius, and a reference angle, your original angle 130 and the reference angle are going to share this terminal side. And this terminal side is going to have all the same x and y coordinates that live on it, which means that we're allowed to use the reference angle to find the sine of 130 degrees. Because if I was to construct a right triangle, it's not 130 degrees that fits inside of it, it's his reference angle that will. So the reference angle becomes a huge part of what we do. All right, I'm gonna give you a homework on finding reference angles. Good luck, guys. Try to practice your anchors.